So hello, good day. So today we want to look at the quotient rule of differentiation, where um, y, which is also f of x, is equals to u all over v, where u is a function of x and v is also a function of x. So in this situation, when we talk about quotient means division. That is the quotient. That is when the functions are dividing each other. So what is the rule for this? So that's the quotient rule of differentiation that we want to discuss today, right? Okay. Okay. So we are going to apply the same first principle that we have been applying in getting our formula. So which is f prime of x is the limiting value as ds tends to 0 of f of x plus delta x minus f of x all over delta x, right? Okay, so just as we did for the product rule, we just add the u to this and add the v to this to get f of x plus dx, x plus delta s, you understand. Okay, so that will be limiting value as delta s tends to 0 of u plus delta u, then v plus delta v minus f of x is what? U all over v. So let us put this dx, let's put it as 1 all over delta x, right? We have not offset anything, right? Okay, so we can find the LCM of this, and that LCM is going to be the limiting value as delta s tends to 0. If you find the LCM of this one, it's going to be v plus dv. That is, you multiply the two, that will be the LCM of the two. Just as when we want to find 1 over 2 plus 1 over 3, what do? We say 2 times 3, 6. 3 and 6, 3. 3 times 1, 3. Plus 3 and 6, 2. 2 times 1, 2. So that's the addition, right? So what we have done is finding the LCM, which is the multiplication of these two, right? So in other words, we are just using this 3 to multiply 1 here, 2 to multiply 1 here. And that will be 3 plus 2, which is 5 over. Okay? So we are doing the same thing here. This in this, that will be v, and v times this. That will be, it's just like you're using v to multiply this. V into u plus delta u minus v in this, that will be this, then this multiply u. So it's like using this one to multiply this. So that will be u into v plus delta v. Okay? And all over delta x. Okay? So that's what we are doing there. Okay? So now, the next thing we want to do here is to expand the brackets. So that will be the limits as delta s tends to 0. Vu, open this, then open this. That will be v delta u minus u times v. That will be uv. Then this times this, that will be minus u delta v. Right? Okay, open this. That will be v squared plus v delta v. And we still have 1 all over delta x here, right? Okay, so at these points now, this is going to cancel this. That will be 0 because they are the same. Now the next thing is this one. Okay, so we can use this dx. We can put it under this and this, right? And nothing has been affected. Not even we do that. So that will be v delta u all over delta x minus u delta v all over delta x all over v squared plus v delta v, right? Okay, so at this point we can say as delta s tends to 0, what happens? Then delta v also tends to 0, right? Delta v also tends to 0. Okay, so delta x tends to du dx, while delta x tends to the v dx. Okay, So by the time we substitute all these in this, we are going to have our f prime of x, which is our dy dx. So it's going to be v du dx minus u the v dx all over v squared plus v times 0, because the v, delta v, is what? Is also tending to 0 as ds tends to 0. Okay, so this one is gone. So we are now having our formula to be v du dx. Let me just put it here, f prime of x. V du dx minus u the v dx all over v squared. So this is the formula, right? So that's the formula for the quotient rule. Okay, so this is our formula for quotient rule. So whenever you have two functions dividing each other, so this is how we use the quotient. We use the quotient rule formula to solve it. Okay, thank you.